uniform gradient annual equivalent amount. In this type of investment mode, the objective is to determine the equivalent amount A of a series with an amount A1 at the end of first year and with an equal increment G at the end of each of the following n-1 years at an interest rate I compounded every period. The cash flow diagram of this investment is, we have a time scale. At the end of first year, there is an investment of A1. At the end of second year, there is an investment of A1 plus an annual increment of G. At the end of third year, there is an investment of amount A1 plus 2 times G. At the end of fourth year, there is an investment of A1 plus 3 times the annual increment G. Similarly, at the end of n minus first year, the investment will be A1 plus n minus 2 G. At the end of nth year, the investment will be A1 plus n minus 1 G. The mathematical representation of this statement is A1 plus G, which is the known value, with unknown A and I interest rate and n interest period. The factor A slash G I n is called uniform gradient series factor. The formula to obtain the annual equivalent of a uniform gradient series is A is equal to A1 plus G multiplied by 1 plus I to the power of n minus I into n minus 1 all divided by I into 1 plus I to the power of n minus I. Here the value of I is in terms of decimals.
Let's now consider an example for uniform gradient series annual equivalent amount. Determine the annual equivalent if a person wishes to invest rupees 15,000 at the end of first year and thereafter he wishes to deposit the same amount with an annual increment of rupees 2,000 for 7 years with an interest rate of 18% compounded annually. So in this particular question, we are supposed to determine the annual equivalent of this particular investment. What is that investment? In the first year, he wants to deposit 15,000. In the second year, he wants to deposit 15,000 plus 2,000. In the third year, he is going to deposit 15,000 plus 2 times the 2,000. That is the annual increment of 2,000 again. And he keeps on adding this particular annual increment up to 7 years. So now we are supposed to determine what will be the annual equivalent of this uniform gradient series. So we'll solve it. We'll write down the given data. So initial investment. That is denoted as A1, which is the constant amount, which is equal to rupees 15,000. Next, equivalent increment. equivalent increment, which is denoted as capital G, it is rupees 2000. So every year there is an annual equivalent, annual increment. Next, rate of interest or interest rate. Interest rate, which is small I. The rate of interest is 18%. So it is 18%. Into decimals I am going to convert 0.18. Now interest period. Interest period N, which is equal to. Now we are supposed to be careful. What is the value of interest period? Now there is a lot of confusions with respect to taking interest period as 7 years. But interest period is not 7 years because it is the annual increment of 7 years. But the investment in the first year, there is no annual increment. So in the first year, it is just 15,000. From the second year, there is an annual increment of 7 years. Therefore, the interest period will be initial investment year plus annual increment years, which is equal to, so initial investment is at the first year plus there are 7 annual increment years. So it is 7 annual increment years. So totally the value of N is equal to 8. So this particular thing is very important. Kindly don't get confused and take the interest period as 7 years, because this is just the annual increment of 2000 for 7 years. But before this annual increment, there is an 1 year investment of 15,000. Therefore, 7 years of annual increment plus 1 year of initial investment. So the total investment period will be 8 years. The cash flow diagram for this problem will be, you have a time scale, you have the cash inflow, you have the cash outflow. Now the value of N for our problem is 8 years. So I will draw a time scale with 8 years. Starting with 0, 1, 2, 3, 4, 5, 6, 7 and 8. Now at the end of first year, the investment is 15,000. Then from the second year onwards till 8th year, the person is going to invest the initial investment plus 2000 of annual increment. So that is, for the second year it will be 15,000 plus 2000. Next, for the third year it will be 15,000 plus 2 times 2000. Next, for the fourth year it will be 15,000 plus 3 times 2000. So first annual increment, second annual increment, third annual increment, and it goes on. For the 8th year it will be 15,000 plus, you can see here, for second year it is just 2000, third year it is 2 times of 2000, fourth year it is 3 times the 2000. So for each year whatever you consider, the increment will be 1 less than that particular year. So you can see here, for second year it is just 2000, third year it is 2 times the 2000, that is 1 less than the year. Therefore for 8th year it will be 7 times the 2000. And you have this year also. You have the investment. So same time it is going to increase. So this is the cash flow diagram for this particular problem. Now we'll calculate what is the annual equivalent. Annual equivalent which is denoted as A, that is the annuity, is given by A1, which is the initial investment, plus G, that is the equivalent increment or the annual increment, multiplied by, this is quite a big equation, 1 plus I to the power of n minus in minus 1 whole thing divided by I into 1 plus I to the power of n minus I. This is quite a big equation to remember, so there is no other option. You are supposed to memorize it. Now I am going to substitute the values into this particular equation. So I'll write it from this end because it is quite a big equation, which is equal to A is equal to A1 is 15,000 plus G is 2000 multiplied by 1 plus I is 18%, 0.18 to the power of n is 8 minus I into n, so I is 0.18 multiplied by 8 minus 1 whole thing divided by I 0.18 multiplied by 1 plus 0.18 to the power of n, which is 8 minus I 0.18. So this is the equation, is equal to 15,000 plus 2,000 multiplied by, we'll calculate what is the value of this whole equation. Okay, 1 plus 0.18 to the power of 8 minus 0.18 multiplied by 8 minus 1. This divided by 0.18 multiplied by 1 plus 0.18 to the power of 8 minus 0.18. This gives us 2.658. So I'll consider it as 2.656. So this value is 2.656, which gives us the annual equivalent of 15,000 plus 2,000 multiplied by 2.656. 15,000 plus 2,000 multiplied by 2.656 will give us annual equivalent of rupees 20,312. So for the investment of 15,000 at the end of first year plus 2,000 annual increment for next 7 years along with the initial investment and bank giving an interest rate of 18% will lead to an annual equivalent of rupees 20,312 rupees.